Okay, so we're gonna do the next set of notes. It should be on the other side of the first set of notes that we've done. This is energy transfer in organisms, or you could just plainly put down food webs. All right. So anticipation guide, the first one, please. Number 5 and 6. Predators and prey are important parts of a food chain, but not producers. True or false? Number 6, decomposers release energy that is cycled back into plants. True or false? All right, so we have a trophic level. The trophic level of an organism is the position it holds in a food chain. And this is just like a basic showing of what a trophic pyramid or the trophic levels are. You've got the primary producers, primary consumers, secondary consumers, and tertiary consumers. And I'm going to talk about each of them in just a second. All right. And like I said, we're going to start with the primary producers. The primary producers are organisms that use sunlight directly to make food through photosynthesis, or if they're not on the surface of the earth and they're way down in the ocean, hot deep sea vents. This is called chemosynthesis. They think that cyanobacteria is down there and they produce energy through the deep sea vents. And all of these are called autotrophs, things that are eaten, basically. So examples, you've got algae, grass, phytoplankton, all of that are primary producers. Then you have primary consumers. These are the organisms that eat the primary producers. They're also called herbivores or plant eaters. So they could also be considered autotrophs because they are herbivores and they're eating the primary producers. So examples we have are the grasshopper over here and a butterfly. And then we're going to have secondary consumers. Secondary consumers eat those primary consumers that eat the primary producers. They are carnivores. These are the meat eaters. Omnivores, animals that eat both animals and plants. So carnivores, meat eaters, omnivores, like us, we're omnivores. We eat both animals and plants. And then you have tertiary consumers. They eat the secondary consumers that eat the primary consumers that eat the primary producers, which make energy from the sun, make food from the sun. All right. And these are heterotrophs. So autotrophs, those are like the prey, the herbivores, that type of thing. And then you have the heterotrophs, which are the tertiary consumers. All right, and then you have something called a decomposer. I know we didn't see those on that chart. That's okay, but they are there. This is a cycle. So this would be when organisms die, you have decomposers, which are organisms that get energy by breaking down the dead organisms. So they get energy, they gain energy by breaking down what's left of the dead animal. Example, worms, maggots, flies, mushrooms, bacteria. So worm, maggots. An interesting side note, they use maggots in the medical industry. Obviously they don't put this on there. They clean and sanitize the maggots, and then they put them into or onto dead flesh that they want to get rid of. And the maggots, the really cool thing about them is they will only eat dead tissue. So if you put that on a wound that has dead skin, necrotizing skin, it will eat that and leave the clean, fresh skin, healthy tissues alone. All right, so food chain. All right, this is important. This is a chain, like a chain link. There's only one. A food chain is one sequence of who gets eat whom in an ecosystem. It typically starts with the primary energy source. Every primary energy source above or on the planet Earth, on the top, on the surface, is the sun. Or if you're underwater, deep down, you've got the boiling hot deep sea vents. That would be the other primary source. The next link in the chain is the primary producer, followed by the primary consumer, then secondary consumer, then tertiary consumer, and then finally at last, which we're not going to see right now, is the decomposers, which is then going to go back to the primary producer, primary consumer, secondary consumer, tertiary consumer, and so on and so forth. All right. So the flow of energy, from now on, we're going to see these arrows right here. Anytime you see an arrow, that just means it is the flow of energy. And here's the thing, as energy flows, as we go from this, the grass, to the grasshopper, energy is lost. And it should be noted the arrow is pointing to who receives energy. So here we go. We've got the sun, that's the primary source, and the primary producers is the grass, then you get the grasshopper, then the lizard, then the owl. And then once the owl dies, the decomposer, and then the grass, and so on and so forth. All right? All right, so we have energy loss, and I just mentioned that. Here's the thing about energy loss and equilibrium. We already saw a little bit of this when we were looking at those aliens in the activity. There are more autotrophs. Remember what I was talking about? Autotrophs, those are the things that are eaten. Then heterotrophs, the things that eat them. As a number of carnivores, heterotrophs, increases in a community, they eat more herbivores, autotrophs, decreasing their population. This makes it harder for the carnivores to find food, and their population decreases too. Eventually, when it evens out, there will be an equilibrium balance, and it limits each other's population. You can't have too many prey or autotrophs. If you get too many of those, they start competing for the same food source, which then causes starvation and death, and eventually it'll equal out. If you put too many predators in, you're going to have competition for those autotrophs, and the heterotrophs will eventually start to starve and die out, and then it destroys everything. So you want that equal living. All right. So we talked about a food chain. That is one sequence. If we add a bunch of sequences together to see a bunch of different possibilities, you will get a food web. It is a network of food chains. For example, we started with that primary source, and then we went to the grass. And from the grass, it goes to caterpillar, it goes to butterfly, it goes to grasshopper, which then can go, these three can go to a rat, or the grasshopper can go to a lizard, and then either the rat or the lizard goes to the owl. So many different ways, and then eventually, like I said, the owl then go to a decomposer. It could be a number of decomposers. All right, quiz time. 1, 2, 3, 4, 5. Which of the following is an example of a primary consumer? Sun, grass, grasshopper, or lizard? Consumer. That's the one you're going to look for. That would be the grasshopper. What does every food chain start with? Has to start somewhere. Where does it start with? This is either going to be the sun or the hot deep sea vents, ocean vents, pardon me. Which of the following is a herbivore? You know, the herb eaters. This one is going to be the grasshopper, at least in this example that we've been seeing today. Organisms that break down complex compounds and dead tissue are called what? The big words to look at right here, break down. Which ones break down? Those are going to be the decomposers. And what happens to energy each time an organism eats another? Each time you see an arrow. Does it stay constant, get lost, gained, or depend on if it's a food web or food chain? They're always, anytime you see an arrow, it means energy gets lost, because it'll take energy to get the energy, and a little bit of the energy is lost. All right, let's go back to the anticipation guide. Predator and prey are important parts of the food chain, but not producers. True or false? False. Producers are an important part of a food chain and food webs. Decomposers release energy that is cycled back to the plants. Do they release decomposers? What was those words I was saying are important? No, they break it down. Every time you see decomposer, you want to see break down energy. Okay, so let's go to the summary. A food chain is a sequence of the flow of energy. What are the two types of autotrophs and heterotrophs? One type of autotroph is grass. And it gets energy from the sun. One type of heterotroph is a lizard, and it gets energy from a grasshopper. Why is energy lost each time an organism eats another one? Energy gets lost each time an organism eats another one because it takes energy to get the energy, which then you lose energy because it takes that energy to gain it. So you get a loss right in there. All right, so that is it for the notes. If you have any questions, please don't hesitate to ask, and I hope you guys have a great day.